Okay, so in the previous tutorial we have seen how we can equip the weapons from the ground like this, and now let's improve these pickable items further. For example, like I need to sort of animate this pickable item so the player can easily see this is a pickable item, plus some sort of a light or like sort of a visualization that can easily seen by the player. So whenever the player see such a visualization on the level, then the player knows actually it's a pickable item, right? So let's add those features to our pickable items. Right, so the easiest thing what we can do is let's open up our pickable item base, and I'll close the rest of the tabs. And the easiest thing that what we can start with the rotations, right? So I'll add a element called rotating movement, right? And this will this can be actually used to rotate the element that we currently have. Okay. So I think rotation rate 180 would be fine. So let's compile and save and play. So now here you can see actually our weapons are rotating, which is what we expected. Okay, but I think sword seems not quite visible enough, which it is rotating or not. Therefore, I think as a workaround, what we can do is we can tilt our sword a bit. Then it will be much more easier to see. But now we have another issue, like when it comes to rotating and other stuff, we need a way to determine what is our forward axis, right? So I mean, if you are familiar with these editing tools, you can figure it out by using this x-axis direction. But I think at the blueprint instance level itself, it's better to have sort of a reference to determine what's our forward axis. So I'll go to the pickable item base, and inside this default scene root, I will add an arrow component. Now you can see actually it is targeted to this x-axis, which is our forward axis. So now if you go to the sword, you can see actually the place where we need to resolve the rotations and the tilt. So for example, if we look at the rifle is actually pointing to y-axis, which is fine. And similarly, the sword is by default pointing to x-axis. Yeah, I think this default configuration would be fine. Maybe I'll tilt it further at x-axis. No, maybe y-axis. Yeah, 20% would be fine. And let's play. Okay, and maybe we can move it along the x-axis as well, but I'm not quite sure. What happened to the rotation value? Okay, it is at the transformation, right? So let's go to the left view and let's set sort of a translation to x-axis. Yeah, maybe 16 would be fine. Because the pivot point for the rotation would be then the center of this sword. So let's play test it again. Okay, now you can clearly see whether the sword is rotating or not. I think the rotation rate is bit higher. Therefore what we can do is maybe we can reduce it for 90 degree. Play it again. Okay, now I think the speed is only added to the sword because I modified it at here. So instead of modifying it at here, let's go to the parent instance itself, and there let's add the rotation as 90. Right now you can see 3 of these instances has the same rotation rate. Right. So instead of manually configuring or directly manipulating our components itself, I think it's nice to have those configurations at our item configuration structure itself, so we can easily tweak. So I'll go to data structures for inventory, and there let's add a new record called maybe I'll add another record to activate the rotation as well. For example, let's say later on if we don't need the rotation for our pickable items, then we can change it by using this variable. So let's say enable rotation, another field for rotation rate is rotate. The default value, I'll enable the rotation with the rate of 90 for the z-axis. And let's go to the pickable item base, and inside the initialize, let's call those variables. And I'll comment this one as well and maybe call it as collision. Right, so let's add a new sequence pin, and now I have these two instances. So how to use those stuff? So let's add a branch here, and if the no, we don't need the branch. Instead what we can do is we can directly get this rotating movement, and we can set auto activate like this. So by default, if this one is false, this component itself won't be activated, which means the element is not rotating. Plus, if it is unable, then the activation will be triggered. So we need to we can actually manipulate the rotation rate as well. So let's set the rotation rate, and as the rotation rate we can use this one. I'll comment this thing as rotation. Okay, and let's play test. So you can see right now all the elements are rotating, but let's say if I make it disable, then neither of them are rotating. Great. Okay. So one part is done. Then we need sort of a visualizer that I mentioned before to visualize our pickable items clearly on the level, right? Rotation actually is visualized at when we are close to our weapons, but let's say we are in too much distance, then actually these rotations are not quite visible enough, right? So we should have a better way of visualizing these pickable items at distance. uh, Plus actually I will disable this collision debug preview at the game, so you can easily do that by going to the sphere collision and mark it as hidden in game, right? So we won't see the box collision boundaries anymore, right? Okay, now so let's create sort of a material to our pickable item that can be used to visualize it clearly. So inside the TPS game, let's create a new folder called materials and the folder called inventory. I'll add a material called m underscore pickable item ring. Right. And this material should be surface and translucent, and by default it should be unlit. Okay. Right, so let's add a vector 3. Now this is a parameter called ring color, and by default I will give sort of like a bluish color is the default color, and we can add a constant, and I will promote it to a variable called glow intensity, and we can multiply these two things together and attach it to the MSU color. Okay, and as the glow intensity by default I'll give it as 50, right? You can see some glow is there, but actually it's a sort of like a 3D planar, but I don't need it to be 3D as it is. Instead maybe let's add sort of a gradient to this one. So I'll add a radial gradient exponential. So let's add outer radius and inner radius to visualize the gradients clearly. So I'll convert this to a parameter called outer radius plus in case if you don't know how to add these constants directly like I used to do, simply press the 1 on your keyboard and click the left mouse button, so it will add this constant to the editor. And similarly, if you need to add this sort of a vector 3 parameter, click on the 3 on the keyboard and press left mouse button, so it will add this sort of a constant, right? So this is a constant, but if you need to parameterize it, then you have to convert it to a parameter. So simply select this one, so it will be a parameter, right? Okay, so as the outer radius, let's plug it to radius, and by default I will give it 0.5, and let's add the density as well. So density outer, maybe like 5. And similarly, we need inner radius as well, which is maybe 0.45 would do. And finally, we need density inner. Oh, the better name would be actually inner density, right? Inner density, and this one for outer density. And density I will give 2 for the inner. And then we can subtract these two together. And before feeding it to the MSU color, we can add another multiplication node, multiply it with the gradients that we have, and plug it to here. Now you can see we have a nice looking gradient effect, right, from here to here. Okay, right. But I think we have sort of like full shaded opacity, so we need the way to actually gray out, or we have to sort of a way to fade out this opacity using this blend mask, which is radial gradient exponential. So the easiest way what we can do is we can multiply it with a constant, maybe like let's say 0.1. So this would be the actual default opacity mask that we have, because either way I'm not going to show the entire of this material. Therefore let's have 0.1 as the default opacity, and I'll add a small comment here as well, so you may not forget it later on when you open the material. And I should be able to manually change the opacity values as well. Therefore I'll add another scalar parameter called opacity, and for this one also by default I will provide 0.1 and plug it to here, and let's plug it to the opacity. Now you can see we have a nice shaded version of this material, but I think maybe 0.2 would be nice, right? Okay, and then we can give sort of a world position offset as well, so it will not look this much of 3D as it is. So let's use camera offset for that, and as the constant value let's go 0.5 offset amount, and as the camera offset let's give this one. Now we can see actually we have sort of offset. Okay, right, so this is our material, and let's create a material instance by using this specific master material. So we have sort of like a configurable material, and we can easily change its parameters from there instead of manually manipulating our base instance. So I'll create a new material instance called mi. Maybe I'll short this as PIR, pickable item ring, green. And for the ring color, now you can see I can change whatever the value that I want at here. So I think for now I will simply change the ring color maybe to green. Later on actually we can change these values as well. And since this is the master material, I will move it to the base folder, so we will not we will have better organization, right? And then let's add that to our pickable item base, right? So the way I'm going to add this material is using a material billboard, right? uh, so you can actually select this scene and search for material billboard, so it will give this instance for you. And here we can insert this translucent material that we had here created here as the default material billboard sprite. So here we have these sprites, and as the elements I will give this material instance, which is PIR green. So here you can see like we already have this glow effect, but make sure to sort of like offset, sort of like reset this offset, otherwise it will be appeared on the origin point, right? So I'll make it as 0. Plus this base size x and y should be configurable based on the pickable item rotation interaction range radius, but I think for now I will keep as it static value, right? But later on, if it needed, we can actually create a function to dynamically adjust that sprite size as well. For now I think the default value or the base size 48 would be fine. Okay, now we have actually this nice looking glow effect. Compile and save. Showcase map. Okay, now you can see actually all the elements have that pickable item ring, but I think maybe we can increase the opacity further, right? Because it's barely visible. So I'll add sort of opacity, maybe 0.5, and it seems okay. Maybe I can even increase it further, 0.7 with the darker green color maybe. No. Okay, this would seems fine. Right, now if I even went to the distance, you can clearly see actually we have sort of like a visualization for pickable items. If the character go there, and he can simply pick those items from the ground. Okay, so that's how we can add sort of a visualization to our pickable items. And I think we are almost done with the inventory item picking logic, and maybe we can further optimize our system, because I potentially see sort of places that we can refactor, like potential logics that we can generalize. Then we can actually reuse those stuff later on in certain different places. Plus we have to work on the dropping part of the equipped weapon as well. And yeah, let's focus on those aspects on the future tutorials. See you there. Thank you.